Today we are on lesson 4. We're going to raise numbers to the 0th power. That's a funny word that just means we're raising it to a power of 0. Okay. So up until this point, we've talked about multiplying. We've talked about raising powers to a power. We've talked about dividing. We've talked about raising fractions to a power. If you need to review any of those, go back and you can find multiplying and dividing in lesson 2, powers to a power in lesson 3. So today, what should this mean? 3 to the 0 power is 1, because any number raised to a 0 power is 1. That also means x to the 0 power is 1, because those variables represent a number. So x to the 0 is also 1. Even if I had 1,267,853 to the 0 power, that would still be 1. Let's look at some examples. You're in the problem set in your book. We're going to use these to show you why this works. So earlier in lesson 2, we talked about subtracting our exponents when you divide with the same base. So if I had 12 and 12 and I subtracted those, I would end up with y to the 0 power. And I told you earlier, anything to a 0 power is 1. Also, you've learned that anything divided by itself is 1. So I want you to try number 2 and see what you come up with. You can pause here and try it, and then we'll go over it when you finish. Okay. We have 9 to the 15th times 1 over 9 to the 15th. I can start by turning 9 to the 15th into a fraction so that I can multiply straight across. So I end up with 9 times 1 is 9 to the 15th. 1 times 9 to the 15th is 9 to the 15th. And just like earlier, I keep my base, subtract my exponents. I would end up with 9 to the 0 power, which is 1. Number 3, 4, and 5. I want you to try those. This is going to be a short lesson. When you get done, we'll go over them. All right. Number 3, anything raised to a 0 power is 1, right? So you do not have to work all of that out. You can see that on the outside, no matter what you get inside that parentheses, it's being raised to a 0 power, which is 1. Okay. In number 4, I hope the first step you made was to make these fractions. And then we can take our numerators, 2 to the 2nd times 1 times 2 to the 5th times 1 over 1 times 2 to the 5th times 1 times 2 to the 2nd. Okay. In our numerator, we're multiplying all of those. I can get rid of my 1s, because anything times 1 is that number. So I'm going to take my 2's, add my exponents, and get 2 to the 7th. In my denominator, I'll do the same. Get rid of my 1s. 2 to the 5 plus 2 gives me 2 to the 7th. And to the 7 minus 7 gives me 2 to the 0 power, which is 1. Okay. And the last one, if I have x to the 41st, times y to the 15th, the commutative property at the bottom tells me that I can swap those out. And it's the same thing. So x to the 41st times y to the 15th. Now I divide my like terms. I would get x to the 0 power times y to the 0 power. 1 times 1 is 2. I'll show you one more. Here, I'm going to use that distributive property that I keep talking about where everybody gets something. So I multiply my x to the 0 times x to the 0. I add x to the 0 times y to the 0. We've already discussed that anything raised to a 0 power is 1. So I have 1 times 1 plus 1 times 1. Use your order of operations, PEMDAS. So I multiply first. Multiply my 1's. 1 plus 1 is 2. So pause here and do the other problem on the other side, and let's see what we get. Okay, you should have worked this problem now. You started by distributing your y to the 0 power. So just like over here, you would have y to the 0 power times x to the 0 power plus y to the 0 power times y to the 0 power. We've discussed that anything raised to a 0 power is 1. Just 1 minute. I'm having some technical difficulties. There we go. One times 1 is 1. 1 times 1 is 1. I add those together and I get 2. So we could say that these are equivalent expressions. So today, the main point you need to take away is that any number, any variable raised to a 0 power is 1. Y'all have a good day.